Welcome to our Everything But the Engine webinar series, where we take a closer look at the components that are driving performance, efficiency, and innovation across Cummins. I'm joined here with Dale Kwasniewski, who is the Senior Director of Product Engineering. Today, we are taking a closer look at the drive axle, its core functions, evolution, and what the future holds. Dale, can you tell us a little bit about yourself and the background?
Yes. So my responsibility is the global drive axle and driveline engineering. I've been with CDBS for 16 years. I've got over 44 years of experience with drive axle design, development, and applications.
And can you tell us a little bit about where we are right now?
Yeah, we're in the Troy Product Center, which is part of the Troy Technical Center here in Troy, Michigan. We're located just north of Detroit.
From your perspective, what's the most fundamental role a drive axle plays in how a truck performs day to day?
Yeah, the drive axle performs three key things. Number one, it supports the payload and the weight of the vehicle. It also is the mounting point for all the suspension brackets. It also directs the torque to the wheel ends. And lastly, the gear ratio is what fine-tunes the performance of the overall powertrain.
So the axle supports weight and transfers torque. But can you walk us through how matching the right gear ratio to the engine and transmission really influences road speed and driver experience?
When you look at the engine RPM and the transmission ratio, especially in top gear, they have to reach a certain road speed. And what we do is we actually take what that RPM is off the driveline and we put in an axle ratio that achieves that. But it has to achieve startability, gradability, but it also has to achieve the fuel efficiency. So the ratio has to be selected in conjunction with all the engine and transmission components and the tire size.
Absolutely. So the axle does a lot of things, right? It also serves as a mounting point for suspension and brakes. How does integrating all of those systems into one component affect the engineering challenges?
Well, the bottom line is the suspensions are built by third-party suppliers as well as the OEMs have their own suspension. So we have to make sure we have places where they can mount their brackets, where they can clamp their leaf springs, their airbags. So that makes a big challenge because it also, the axle has become part of the suspension in some cases. So we've had to make sure that we validated the housing to take those structural loads. When it comes to the brakes, we have disc brake and drum brakes. Used to be you had a brake flange and you just mounted everything to that, but now we're integrating torque plates and S-cam spiders. And that whole idea is to maximize the weight because you can save weight by getting rid of one of the elements. So it becomes a challenge again to designing the axle housing to take the suspension loads, take the torque, but at the same time manage what the brakes have to do.
How do changes in axle design directly translate into measurable differences in efficiency and emissions output?
Well, the drive axle, again, you select a ratio with the transmission and engine to get you a certain performance. But at the same time, if you want better fuel economy, you have to do things with downspeeding, so selecting a fast ratio. You also have to look at, in some cases, employing our lube management system, also looking at our fuel-efficient bearings, and our optimized gear designs, including the spiral bevel design that we've worked with on this 14XHE.
So you've talked about a few different things there,
Yeah.
Specifically on that spiral bevel design. Can you tell us a little bit more about that?
The spiral bevel is a gear design to where the pinion is on center with the ring gear. The reason they do that is because there's no relative motion between the two members. On a hypoid gear, which is below center line, there's actually different spiral angles, and so there's sliding friction. With a spiral bevel, it's more rolling, and so therefore we employ that. But there's also things you got to worry about with the spiral bevel. You got to make sure it's sized appropriately to manage the torque. But again, we've been doing this for 100 years, so we've got a lot of experience with design, development, and manufacturing of gear sets.
Out of those 100 years, you've been working on these things for 44 of them, right?
Yeah.
What are some of the changes you've seen over your time?
Well, the biggest thing is when I started in this business, a fast ratio in an axle was 3.55 or 3.70. Those days are gone. Today, pretty much the standard ratio on a line haul tractor is 264 to 1 or 279 to 1. Then we've got 247s as well. But now when we've moved to direct drive transmissions, we can go even faster, which is we've got a 2.15 to 1 as well.
So we've switched things up a little bit. We've brought out a new product. Dale, we were talking about the faster ratios, right? Can you tell us about the challenges it took to design an axle that could handle faster ratios while still holding up to heavy loads?
Sure can. So what the product we've rolled in here is our MT4014X. This is our flagship product. This is what's used in just about all of the products we sell on the highway with the line haul tractors. So this product was designed only about 10 years ago. And the first thing they did is they had to make sure they had a full range ratio. So when I started in this business, a fast ratio was 3.55 to 1. This axle can go to 2.15 to 1. So when we designed it originally, we designed it for a 247 ratio. Then when we did that, we actually put in bigger bearings, bigger interaxle differential. We made sure our gearing was optimized. We put in bigger diff case bearings, a bigger input shaft. The whole point was to handle the startup loads from the faster ratios because you don't have the reduction anymore. And so this product right now, again, can run as fast as 2.15 to 1. And we've got product that's in the mix right now being developed that can actually go down to 1.95 to 1. And that's in conjunction with the new Cummins max efficiency powertrain.
So the 14X introduced several efficiency features. Which of those innovations had the biggest real-world impact?
The biggest one was what we call the Meritor lube management system. It basically takes the oil from the axle sump, moves it out into the arms of the housing, reducing the churning losses, but it also cools the oil. The beauty of the design, there's no pumps, there's no computers, there's no valves. It's very simple, and it works. That was probably the biggest achievement. Matter of fact, that's what pushed us over the hump on getting certain efficiency values. But we also did things like we put in high efficiency or fuel efficiency bearings. And we rely on outside sources. We buy the bearings, but they're crowned. We've got certain surface finishes. The rollers are designed a certain way, and it's to reduce the rolling resistance under load of those bearings. The other thing we did is we introduced spiral bevel gearing in the rear axle. Spiral bevel gearing reduces your sliding friction between the gear teeth, and that basically improves the efficiency as well. And then lastly, we lowered the oil level so that, again, you're not churning through as much oil. But when you do that, you had to design the inside of the axle to where you're maximizing the circulation of the oil to lubricate key points. And the other thing we did is, like I said, we had to make sure that the input shaft, the interaxle differential, all were beefed up to handle these startup loads due to the fast ratios.
So all of those parts and points that you just mentioned, what do you think was the biggest challenge that you guys overcame as you were engineering this piece?
I think the biggest challenge, again, was make sure that the gear ratio could manage the loads, but we also had to hit the efficiency targets. And really the biggest thing that helped us was the lube management system, and on top of that, reducing the oil level. Yes, the fuel efficient bearings helped, the spiral bevel gearing helped, but at the end of the day, the lube management system is what really pushed us over the hump.
So Dale, for tandem axles, can you explain how the interaxle differential works and why it matters in everyday fleet operations?
Sure. The interaxle differential is a straight bevel gear tooth combination device that averages speed and divides torque. So, or splits torque is the better way. The differential is very critical to basically to make sure you don't damage the axle. So on the interaxle differential, which is up inside of the forward axle of the tandem, that splits the torque from the input shaft to the rear through shaft to the forward gear set. And what that does, if you don't have that differential and you have slight tire mismatch, then you're going to get wrap-up torque. If you go back to the 50s, a lot of trucks didn't have interaxle differentials, but truck life was much lower and weren't the expectations. But sooner or later, they realized if they wanted to have a durable drivetrain, they had to put a differential in there to relieve the wrap-up torques caused by mismatched tire sizes. Now, we have what we call an interaxle differential lock, so there's a way to lock that differential out, because the downside of a differential is if you got split coefficients of friction, the vehicle might just sit there. You got one wheel spinning on ice, and the other side is just sitting there. That's because it can't develop any more torque that's being developed on the slippery surface. So what we do is on the forward axle, we have what we call an interaxle differential lock. That slides a clutch and locks that function out, and now you're splitting torque 50-50 no matter what. No matter what happens, torque is being delivered to the axles. But you still have the cross locks, which is a different story. That's the full differential locks. Those are very specific use, mainly vocational.
So those cross locks, right? When would those be used?
They'd be used if you were prescribing a dump truck, or if you were working on a heavy haul, or you were working on a mixer or a garbage packer, where they're going to go into slippery terrain, deep snow, deep sand, deep mud. They need maximum traction, so that locks out the crosslock locks out the wheel differential, and it maximizes the tractive effort. However, it also impacts the handling, and that's why a lot of times you got a specific driver operating that vehicle because he understands that he's going to have understeer. But it became popular really starting in the mid-'80s. Everybody wanted to go to a crosslock because it was used in Europe for many years.
So the 40K tandem market evolved from one design to 5 different models. What drove that expansion, and how should fleets think about choosing the right configuration?
Well, that's a really another good point because, again, my history going back in time, everybody thought you could get by with one 40,000-pound tandem, but you couldn't because this tandem required certain durability, but this tandem needed to be lightweight and fuel efficient. So that's why if you look at the 14X, we have a family called the HE where it has a different rating and a different application for maximizing fuel efficiency. But if you've got a dump truck or a garbage packer or heavy haul, you got a 14X that doesn't have the high efficiency bearings. It doesn't have some of the fuel saving features because that's not what they're interested in. Their starts and stops. Dump truck drives behind a newly built house and a foot of sand. He needs certain capability that you don't want a line haul axle for that.
The next generation tandem axle is targeting gear ratios as fast as 1.95 to 1. What kinds of applications will benefit most from that leap?
Anything like that with those fast ratios, those are going to be the people cruising on the highway. We call them line haul applications. So they're going down I-94 and they're going to drive 200 miles, 100 miles between stops. They're trying to maximize the fuel economies and reduce emissions, obviously. So the fact that what that drives is that they turn around and they have an engine, a transmission, and the axle that all packages and gives them that fuel efficiency that they're looking for. But at the same time, the driver wants to make sure that the vehicle doesn't have shifting going on constantly. So that's why the engine and transmission and axle have to work seamlessly, and that's, again, what we're doing with the max efficiency powertrain.
So how does working alongside Cummins engine in the Eaton and Cummins JV shape the way you approach innovation compared to developing axles on your own?
Well, I think the biggest thing we're gaining from being part of Cummins is the fact that we can get information from the engine team that we couldn't get before because of the proprietary nature. Same thing with the Eaton JV. They are sharing with us certain things that they're doing that helps the axle. We all have to protect our components from being abused, and before we had a hard time getting commitment out of the OEMs and out of the other suppliers. So now we have things that are going on in the transmission and the engine that not only maximizes fuel economy, but it also protects the overall drivetrain. So I mean, that's critical, and I think the other thing that's come out of it is there's innovations that they're offering that we're leveraging, but at the same time, you know, we're known for our gear technology. We have a brand new gear lab right here in Troy, and we can then help the Eaton JV, we can help Cummins with our expertise in gear design, development, and manufacturing.
Looking ahead to maybe 5-10 years, what role do you see axles playing in future vehicle architectures like electric or hybrid drivetrains?
The hybrid drivetrain is going to have a place. On line haul, it's going to be still difficult because of the range. The biggest thing you're going to see is things that were out of reach, not technically, but cost. People are going to recognize that I want a more efficient axle. Well, you got to do this. Well, that's going to cost extra money, but we get to your target. We help the environment. We improve fuel economy, but we help the environment. That's the key thing. So what I see is going to come are things that maybe were talked about 20 years ago, but now they're reality because, number one, they're within reach and they're needed.
With all these changes, what excites you most about the future of the drive axle?
I think exactly that. I mean, there's things we've got on the drawing board that we are going to investigate through our research programs that are definitely going to be critical to determine if some of these ideas that we tried to look at years ago are going to be brought to reality. We're going to be basically running test trucks probably by the middle of next year with ideas that we may not see till 2029. But it's because we're basically using new technology and we've got to prove it out.
So we've talked about a lot of different things, from the history to the future and the present. If you had to sum everything up in just a short little, sentence or two, what would you say is the most impactful thing that we've talked about today?
I think the most impactful thing is still the technologies that we introduced with the 14XHE tandem, which again is the lube management system, spiral bevel gearing, which again, that's important because we not only know how to cut gearing, we know how to design it, we know how to optimize it. And then of course the fuel efficient bearings and then reducing the lube level. Those were all impactful. Again, one more time, the lube management system is so simple and it works, but what it does, it allowed us to reach efficiency levels we couldn't have reached before. And it works.
So we're going to move into the Q&A portion of our event. So if you have any questions, please submit them to the chat or the Q&A function, and Dale will do his best to answer what he can.